So for number one on the review packet, we have parallel lines. So that's going to make these angles congruent, and as well as those. So we have similar triangles. So we'll redraw this. One strategy to use. To be careful here, put these together. And if we're looking for EC, which is what they want, call it X. So that whole side we have to say is X plus 10. And now we'll use corresponding sides are proportional. So I'm going to match up 6 and 9, 10 and X plus 10. So 6 is to 9, as 10 is to X plus 10. Write the equal sign, and let's multiply diagonally. So cross products are equal. Distribute, and X equals 5. So E to C is 5. The whole side would be 15, but E to C by itself is 5. Okay. So AC parallel to DB. We're going to use alternate interior angles. Could use vertical angles, but this works too. AC is 3, DB is 4. Okay, so the ratio of the sides is going to be, we can say this is top, all right? So we could say it's 3 to 4. Now this one's extremely tricky. So if we don't know what these are, what we can do is we can call A to E. We want that one, so let's call that X. But now when A to B is 14, right? So you've got A to B is 14. If A to E is X, this is a math, this is one of the tricks that we use is this could be 14 minus X, right? And then these two would add up to 14. So this is one of the strategies. So we could say X over 14 minus X. There's another strategy calling it Y, and then we'll just have to do systems of equations. But write the equals, 4 times X, 3 times 14 minus X. Add 3x to both sides is how I would do it. Those are gone. X is 6. Let's just make sure. Does that? So if that's 6, then that's 8. Yeah, that looks good. So A to E is 6. So for number 3, here's the measure of the sides of one triangle. Now identify 6. That is the smallest. They're giving us the smallest side of the other triangle. So we can put these on top. They want the measure of the longest. Okay, so the smallest are 6 and 4. The smallest on their respective triangles. The largest, of course, on this one is 15. And the longest on the other one is unknown, so we'll call it X. Write the equals. Calculate the cross products. And divide by 6. So if I don't like the longest side is 10. Okay. Doing good here, about 4 minutes, 5 minutes, okay. This is one of those questions where we don't have corresponding sides. We have to work for them. We could notice these three right here. What we have is a Pythagorean theorem problem. So let's call this, all right, so x is spoken for, so let's call this y. Okay, so we'll start with a Pythagorean theorem problem. 16 squared plus y squared equals 34 squared. I better go get a calculator for that. So this is 1156. Subtract 256. Y squared is 900. Square root both sides, and we get 30. Now that's just getting us to here. What we need to do now is work for x. What we want is corresponding sides to be proportional. If we look at this, 45 is going to go and correspond with the 30. 16 is going to correspond with the x. Let's just put these on top every time. So 30 is to 45 as 16 is to x. Now what you're noticing is that I'm kind of matching these up. I use a highlighter, some kind of symbol to tell you which pairs of corresponding sides are which ones they are. So 30 goes with 45, 16 goes with x. Now we can solve. So 30 times x, 45 times 16. We get 30x equals 720. And x equals 24. Okay, so that is what they wanted. So we'll take the information here. Isosceles, okay, those are same. Kn. Make sure we mark this appropriately. Don't put a single slash on those. That would be a mistake because we don't know that they're the same. Okay, so they are similar. They're telling us they're similar. What we're looking for is, let's see, they want x. We know this is 34 degrees, right? If they're similar, these are definitely corresponding. So corresponding angles of similar triangles are congruent. So let's just focus on this triangle right here. If the vertex angle is 34, we're going to go 180 minus 34, 146, and then take that and divide by 2 to get 73. So these are both 73 degrees. That's it. Okay, let's see if we can get one more in on this one. So some isosceles triangles are similar is true. Okay, sketch a pair of isosceles triangles that are in fact similar. Okay, so isosceles, I have to satisfy that. Say I make these 10s and these, I don't know, 5s, just to make it easy. And yeah, I don't know what the third side will be, but maybe I can make up a angle measure of 50 degrees. Here, I don't want to commit to what the third side is because I could be wrong. Yeah. Oh, include all angle measures. That's what I was looking for. Okay, so if I do this, I want to be careful here. 180 minus 50 is 130, and then I'm going to want to go 130 minus, or 130 divided by 2 equals 65. So for me to do this, I've got to include the angle measures. I didn't have to include the sides, and you definitely don't want to put this side in because you could be wrong, and then we have to take off for it. So good enough. Those are similar. They're not congruent. Okay. Sketch a pair of isosceles triangles that are not similar, and again include. All right. So we could have tens here again. Let's just use the same one. 50, 65, 65. We know that one works. Then we could write this one. Well, let's see, we kick that up to 70. Now these would be the same as each other. They could still be we could still use the 5s, but that angle is definitely going to be different. 180 minus 70 is 110. 110 divided by 2 is 55. So these are both going to be 55s. Now I included all my angle measures, showed my work for it. This would make them true. These are similar. These ones over here. Okay, and these are not similar. All right, that's it for this first session. So we'll come back to the rest of them in another one.